So first, what are white dwarfs? White dwarfs are the exposed degenerate core of the star. They have about planetary dimensions. You see here a typical white dwarf compared to the radius of the Earth. Their spectral types are subdivided between A, B, and O. A means that they have a lot of hydrogen. That's the A spectral type. White dwarfs of the A spectral type. White dwarfs of the B spectral type, as you imagine, they have a pure neutral helium surface. And the O spectral type, they have ionized helium. So the A is for hydrogen lines, B is for neutral helium lines, and O for ionized helium lines. And there are also white dwarfs that are just exposed core carbon and oxygen with no spectral lines. Because they're very small, even though they're very hot, their luminosity is low. So in the HR diagram, they lie much below the main sequence in here. And white dwarfs do little but cooling. So the white dwarf has no energy production. They're completely supported by the generate pressure. And the cooling, this cooling time scale, takes a long time. It takes about 10 to the 15 years. If you give the temperature of a white dwarf and you know the luminosity, you can easily calculate what the cooling time would be. It's E over E dot, the energy over the luminosity. You would take about 10 to the 15 years to cool down to the background temperature. So the universe is not old enough for a white dwarf to have cooled all the way down to the background temperature of the universe. The coldest white dwarfs known have still a temperature of about 5,000 Kelvin. And because there is no energy production, from the structure equations of a star, which still apply to the case of a white dwarf, that means that there is no temperature gradient. White dwarfs are essentially isothermal. You remember from the temperature equation, the temperature gradient is proportional to the luminosity. Now, if the core has no luminosity on its own, then the temperature gradient is zero. So the structure of a white dwarf is very simple. You have an isothermal core, and there is a very thin zone where the temperature changes, where the atmosphere is exposed to space. So this here would be the temperature, fairly constant, and then drops. And from that, you can use your stellar models to calculate what the density would be.